Hey, Barry.
Yeah. I think Stacy is not going to be here today,
Okay. All right.
but she says hello.
All right. I have my collected notes. And just so we review, you remember, according to my notes, we started this new format on Sunday, April 24th.
Okay.
And just to go over a few items, just to jog your memory, I said I was going to take a micro leadership role. We're going to use RFCs as foundations for agreements. We're going to try and converge on behaviors. We're going to try and promote the usage of shared group memory. We're going to try and follow the 9 artifacts guidelines. But here's the interesting thing. I believe that I did go over this next section, which is called levels and modes of participation. And I have 5 bullet items underneath it. Okay? If you like, I can share them on screen.
Well, I certainly don't remember them.
So what?
I certainly don't remember them. I haven't memorized any of this stuff.
Okay, anyway, I'll go back to April 24th if necessary, the video. Anyway, so I did suggest that if someone agrees to the guidelines above, they become a full participant. And I had parenthesis yellow belt. If they agree, but they're demonstrating inconsistent adherence, then they're kind of a provisional participant, they're a white belt. If you don't agree, but there's still good adherence, then there's still a white belt status. If you don't agree, and you're not in good adherence, then you get no belt and you're an auditor for this unless removed. But removal consists of if you really disrupt group flow and conversation, and especially if you do it more than once. Okay, so that's what I would just wanted to review with you. And evidently it doesn't jog your memory, so I will do some more verification. But these are my notes from the format shared on April 24th.
Yeah.
Now, I'm doing this for the record because I do think that there was a disruption last week. In fact, there were names used and there was quite some discussion. So I didn't want to just brush that under the rug. Okay, so anyway, that's just context for whatever might
Well,
arise
no.
later today.
So if I stray, you're just gonna have to point that out to me, because since I don't have these things completely integrated and memorized, I will potentially stray inadvertently, and you're gonna have to catch that if it happens, because
Of course, that's what
I
I mean.
haven't learned the rules of the game. And I'm very, very poor at memorizing the rules of the game.
So I know you have an abhorrence for rules in first place.
Well, this is they're hard to memorize, and even if you can memorize them, they take forever to process what's a legal strategy that is advantageous but still legal, and that takes a lot of work. And I'm just not very efficient at that.
We'll get you an attorney.
Sorry.
We'll get you an attorney.
Oh, that's exactly what I don't need. I'm too cheap to have an attorney.
There is no law at the moment. Yeah. All right, Barry. What's happened in the last 24 hours?
I'll tell you one thing that's happened. So you know that I like to watch these science education videos on YouTube. There's a handful of presenters who are really good explainers of sophisticated science. And one of them is this German lady named Sabine Hofstetter. I don't know if you recognize
Yes, I've seen a number of hers. She's quite thorough and, treats a wide variety of topics with interesting approach.
Yeah. So yes, I'm pretty sure it came out yesterday. I think it was yesterday, or maybe it was 2 days ago. She did a reprise on cold fusion. She talked about the fact that cold fusion kind of comes and people get excited about it, and then people get disillusioned, and it fades, and then there's sort of revival. And so she did a reprise of discussion of cold fusion. And I don't know if you're aware of this, but about 10 years ago, I took a very good hard look at the surviving enthusiasts, the cold fusion hardline, enthusiasts, because I was interested in where are they departing from the protocols of the scientific method such that they are believing things which are scientifically incorrect, but subtle. Where are the subtle discrepancies? I was looking for, from the point of view of science education, can you identify the departures from the protocols of the scientific method that are responsible for them believing something that is incorrect, scientifically incorrect? And it tends to be subtle down in the subtle mathematics of the models that they're using or abusing. And in the process, I came across probably the most prominent and most respected diehard participant, which was this guy at SRI, Stanford Research Institute, named Michael McCubre. And he was funded by the Electric Power Research Institute, EPRI. And so he was trying to, do very precise measurements to show that he was getting more energy out of his electrolytic cells than was going in with his electric power supplies. And he was featured in an episode of CBS 60 Minutes with Scott Pelley as the correspondent. And so there was this question of, is McCubre really getting nuclear power out of the system, or is he miscalculating the amount of thermal energy coming out relative to the electrical energy going in? And what was interesting about this episode is that Scott Pelley at CBS brought in two experts to present, the criticism of McCubre's work, like you would do in scientific peer review. And one of the guys he brought in was a guy named Richard Garwin, who was, he had been on the president's scientific advisory committee, but more importantly, Richard Garwin was one of the people who helped develop the hydrogen bomb back in the 1950s. And he worked out, he had all the mathematics and all the physics, and he worked out exactly, how you would have to design a system that you could actually get thermonuclear energy out. And so when Pelley got around to interviewing Garwin, Garwin said, I think McCubre is not measuring the input electrical power correctly. Now you think, okay, you got a power supply, it's putting in voltage and current, you put a watt-hour meter on it, a precision laboratory watt-hour meter, and you get exactly how much electrical power is going in. How can you measure it incorrectly? That was sort of raised an eyebrow. So I went back and I looked at McCubre's paper, and he had written a technical report, not in a peer-reviewed paper, but published under the imprint of EPRI, his funding organization. And in it, McCubre explained exactly how he was computing the input electrical power. He was using a constant current power supply, essentially what you would call a battery charger. And he noticed that as he was charging up his system, it's basically, when you charge up, it's like an electrolytic capacitor. You got an anode and a cathode and an electrolyte in the middle, which is heavy water, and you're driving a current in and you're charging up the plates. You're sending protons and deuterons into one plate and electrons in the other plate, and you charge up, the voltage rises basically like electrolytic capacitor. And instead of actually measuring in real time the voltage and current and multiplying them and integrating them, he was saying, well, I'm using a constant current power supply, so I can just take the current as constant. Now I can see the voltage is going up and down, but if I take the average voltage and multiply it by the constant current, I get the total power. No, you get the DC component. You're going to have AC transients because the resistance is fluctuating. As resistance fluctuates, you get AC transients, and you've left them out of your calculation. And I think, all right, so I was better than average student in electrical engineering. I actually graduated top of my class, but I said any of my classmates in sophomore electrical engineering would have said, no, you have to reckon the AC transients. And I went down, I said, oh, this is basically a homework assignment in sophomore electrical engineering, compute the amount of power in the AC transients if you have a fluctuating resistance into a constant current load. And I worked it out, and exactly the amount of omitted AC power was the excess heat he was getting out, almost exactly. And I said, well, this isn't terribly profound. It just explains why he's getting the wrong answer. And I wrote it up and I published it, not peer reviewed, just wrote up my notes. Eventually, EPRI stopped funding McCubre at SRI. They didn't say why, they just stopped funding him, and he shut down his project and he went back to New Zealand and retired. And there was never any revelation of why his system didn't work. There was never any revelation of what mistakes were being made in terms of the mathematical models being used, the calculations, the measurements, the blah, blah, blah. And so there was these diehards who never gave up their belief in this cold fusion, even though the technical analysis, and that's technical, it's calculus and electrical engineering and, models, they never gave up. So Sabine Hofstadter, reprises this story. And so I just feed in a little note, by the way, here was the main reason why there was a discrepancy between the heat coming out and the power going in. It was this mismeasurement of the electrical power. Well, who turns up to try to discredit me is but Jed Rothwell, the remaining scientist or pseudoscience journalist who's still talking about cold fusion. And he comes in the comments in Hofstadter's and Hofstender's YouTube video, and he says, no, you're wrong. He just dismisses it. And so, all right, I pull out the details and I write up, here's exactly where it goes wrong, and here's why, and here's all your hand-waving arguments to trying to dismiss it are simply baloney. And so that's what happened yesterday, since you asked.
So did Sabine
and I'm sort of waiting.
Respond?
No, so I responded right after Jed Rothwell, the diehard journalist, and I was waiting to see if he would come back and try to rebut, which he hasn't yet. It's been about a day now. And I don't expect Sabine Hofstadter to do it because I've noticed that in the lengthy comments of her YouTube videos, she almost never comes into the comments to comment on. So she'll let people debate things in the comments, and she'll never go in and try to sort it all out. At least I've never seen her come back in the comments. Now, other presenters in these science videos, Arvin Ash, for example, more commonly will enter the comments and respond. And for example, Arvin Ash has responded to me. He did one on Bell's theorem, and I pointed subtle mathematical elements that's neat that you can't overlook. And it has to do with the fact that, and I've talked about this before, if you have two things that are perfectly in sync, like this, okay, they're in phase lock synchrony. If you move them apart, they will decohere. Why will they decohere? Because timekeeping is local. If there's a gravitational gradient along this path, they will get out of sync with each other. So their general behavior will remain the same. The mean shape of their precession or whatever it's doing will remain the same, but they will get out of phase with each other. And so you'll have a perturbation around some mean characteristic, and the mean characteristic will stay the same, but the perturbations around it will get out of sync. And that's the tiny discrepancy that's omitted in John Bell's mathematics. He assumes that timekeeping is the same, like Newton did. And if you allow that the timekeeping varies because of gravitational gradients, then you have to throw that into the math. And if you don't, you get the wrong prediction. And that's not a complicated thing to appreciate, but it's almost never pointed out in a way that the average person can really appreciate it. Arvin Ash is one of the few guys who said, that's a really interesting point. And then I said, it would be great if you could sort of introduce that in one of your future presentations, elucidate that. He never did. Go ahead, Joshua.
Oh, I was just going to share, I think I saw a Veritasium episode on that exact point with clocks on a ship and how they all synchronized. So
Yeah.
it was pointed out for the general public. I don't know if any, I usually they get a lot of views. So I think that's yeah.
The one with the clocks on a ship is the problem of longitude, because if you want to measure your east-west position by reckoning, the elevation of the moon or a star or something, you have to know the time to within 4 seconds of the correct time, or else your east-west measurement will be off by a mile.
Right. That's how the video started, explaining that aspect.
Right.
But then it went in to explain what you're talking about with gravitational pull. I don't know about gravitational pull. I didn't understand it quite,
Well,
but I do know.
this is the
the
point
phase-
that Einstein, this is the point, see, in special relativity, which is 1905.
Well, I saw the video, so you don't have to explain it to me.
Yeah.
It's okay.
So
He
anyhow,
went into all of that. Yeah,
but he didn't do it with respect to Bell's theorem. I don't think he did.
I think he did. I'll go back to it. How about you keep talking? You want me to go back to it and check?
If you can find it, because I
Yep.
have followed all of these presentations of the Einstein-Podolsky-Rosen paradox, the EPR paradox, and why the tests of Bell's theorem always show that Bell's theorem is wrong. And the question is, why is it wrong? The math looks correct, but the math assumes that the clocks are in sync. And if you throw away that the clocks are in sync, then you get a phase shift, an unpredictable phase shift, and that phase shift, that phase differential, can explain why Bell's derived inequality is incorrect. He gets a straight line relationship, and in fact, it's more of a sinusoidal shape. And where does that sinusoidal shape come from in reality? It comes from the decoherence of the phase component. So if you've got this going on, the up and down are staying the same, but the phase of the perturbation, the precession around it, is out of phase. So you have a tiny perturbation which is out of phase with the part that's constant. That's never really pointed out. And if you admit that, I mean, if you deny that, then you say, well, then fMRI machines don't work. Or if you take Macubray's simplification, then telephones don't work, because all the things that make an fMRI machine work are precession of the magnetic moment around some mean, because that's really where the information is coming from. And telephones work because when you vary the resistance in the carbon transmitter, that gives you a fluctuation in the signal. You modulate the DC, and that's the signal that's got energy in it. So all these things are subtle but profound and not easy for the layperson to appreciate, because it's these second and third order effects which you really care about. Is that clear, Sam, or am I sort of
I
being
think that is
incoherent?
clear. But I'm also curious why the guy used calculations rather than actual measurement. So I'm actually,
well, because if he used, see, when they try to replicate this at MIT, the original Pons and Fleischmann, they put a real watt-hour precision laboratory watt-hour meter to measure the power going in. And I'm going, well, yeah, that's what else would you do? Well, because Macubray wanted to regulate the drive current going in, he used a constant current power supply, but he assumed it was an ideal constant current power supply. Well, real ones, they have what's called a slew rate. If the load changes, they have to raise the voltage or lower the voltage, and it doesn't do it instantaneously.
Right.
And if you figure out that when it's slewing, the voltage and the current are in phase. And so you're getting an AC transient, a traveling wave that's in phase, and then you got extra power.
So I have another question. That is, if indeed he had achieved cold fusion, and cold fusion releases energy,
Right.
I doubt that in his attempts, and this is just me speaking as a layperson, he would have had the controls to keep that energy release regulated. So I'm thinking, hey, if he did actually release energy, why wouldn't he have just had a big explosion?
In fact, he did have a big explosion once, but it wasn't from cold fusion. Once you've charged up the electrolytic capacitor, so there's no more position in the lattice for protons or deuterons to fit in the lattice and no more room for the electrons, now you start dissociating the hydrogen and the oxygen from the water molecules, and you start getting gas bubbling up to the top. And this gas bubbles up to the top, and if you let it bubble up too much, if you start to dissociate the water, you've got a hydrogen oxygen gaseous mixture, and if there's a spark, you get an explosion. You get the Hindenburg. And one time in one experiment, that's exactly what happened to Macubray. One of his cylinders exploded. Now, it wasn't exploded from a hydrogen bomb, it exploded from a Hindenburg bomb, and he has a piece of shrapnel in one of his legs. So they had to sort of regulate these things so they didn't overdrive the thing and get hydrogen oxygen dissociation to the point where you had a combustible mixture of gases sitting inside this closed cylinder. And they put in, these recombinant things to recombine them, and you get a rainfall thing. But you didn't want to build up too much gas, because then you have the risk of an
It's still, it's
explosion.
the wrong kind of explosion. It's not the one that verifies that he had fuel.
No, it was the explosion that they go, where did this energy come from? Well, they didn't think that, well, it was from the dissociation. And the other thing, so like Jed Rothwell comes back and he says, well, but there's this thing that they call heat after death. That is, after you turn off the power supply, you're still generating more heat. I say, yeah, because you've got this big electrolytic capacitor, you've charged it up maximally, you turn off the power, now these protons and these electrons are going to diffuse back in and recombine, and you're going to get, you've got, this thing has a capacitance, call it capital C, and you got a voltage across it. So how much electrical field strength energy? 1/2 CV squared. Sophomore electrical engineering. You've pumped in 1/2 CV squared worth of electrical energy that's stored up in this charged capacitor. And now you turn off the power and it discharges slowly at the RC time constant rate. And it's going to generate more heat for the same amount of time that it took to charge it up. You're going to discharge it at roughly the same rate, and you're going to get generating more heat. But it's not heat from fusion, it's heat from discharging a charge up capacitor. That's not complicated. But where do you see this in the energy budget model? It isn't in there. There's no 1/2 CV squared in the model. There's no AC component in the model. I'm going, my God, if this had gone out for peer review and somebody with, undergraduate electrical engineering knowledge, it was said, your calculations omit 2 factors, which are absolutely essential to include in your energy budget model.
I mean,
You pretend that they don't exist.
But the energy released is only gotten when he turns off his device.
Right. He says that, and this is true. Once you stop charging it, you turn off the power supply, it still continues to generate heat. Why? Because the capacitance that's been charged up to full is now, it's like discharging your battery internally.
Right.
And so the thing will slowly discharge because all those protons and electrons have to diffuse back in and recombine.
But see, if that's where you get your energy, then is the claim that you only get energy out of this device once you turn it off, which is kind of a strange claim to make.
Well, the point is that the heat after death, quote unquote, was the narrative explanation of this discharge in capacitance. They didn't call it that. And that was a claim that they were still getting fusion. So they claimed that they were getting fusion all along, because leaving out the AC while you're charging it is one place where you're getting more heat out than your DC putting in. And then the discharge of the capacitance is another place where you're getting more heat out than the electricity you're putting in. But you can't leave those out of the analysis. And he basically deludes himself.
Last question, Barry, on this topic.
Okay.
Who other than Makubre and his tribe were promoting this idea that cold fusion was successful? Were there other camps?
Yeah, so in Sabine's video yesterday, or whatever day it was, Friday, she mentions 3 people. She mentions Edmund Storms. She mentions a guy named Rossi, who was trying to sell these things in Italy. And I'm trying to remember. Well, she never mentioned Makubre by name, but she described three deficiencies in the analysis. And I pointed out that I said I never communicated with Makubre. I wrote up my criticism of him, but Edmund Storms I did communicate with. I had a long email exchange with Edmund Storms, who Sabine does mention, and I said, I asked him a basic question that you would ask in any scientific study where you're trying to prove an effect that's over and above what you normally expect. And I said to him, how did you falsify the null hypothesis? That what you're saying is just an ordinary, well-understood process. And to my astonishment, Edmund Storms says, we don't use the null hypothesis in chemistry. It doesn't apply. What? So I ended up writing up this whole, report of my conversation with Edmund Storms. And in my comment on Sabine's video, I gave links to both the Edmund Storms conversation that I had, that he's departing from the protocol to the scientific method, and also the Macubre omitting the AC noise component, so, the AC energy component. So I put both of those in, and unsurprisingly, because if you look at comments on YouTube videos, there's almost nobody reads them. They might skim them, but almost nobody will respond to them. The only guy who responded was Jed Rothwell, who's this diehard journalist who's trying to preserve, some sense of that it's still alive.
So what's in it for him to keep this alive, other than that he becomes the journalist who's covering?
Because he still wants to write articles in pseudoscience journalism and claim that it's science journalism, and that there's still some validity to this thing, and he has to gloss over or dismiss the peer review criticisms, which are valid. He basically has to find some way to brush that aside. And he thought he could brush me aside, and maybe some people will look at it and throw up their hands and say, well, I don't know who to believe. And if I give the technical analysis, it's going to be over the head of most people. Not over your head, because you have enough, mathematics and background to follow it. But 95% of the general public will go, I have no idea if what Barry says makes any sense or not, because I don't have a degree in electrical engineering. I don't know what 1/2 CV squared is. I don't know what AC signal energy is. I don't know how a telephone works,
I haven't read the peer review articles about cold fusion, but it's a topic coming back into the mainstream. But what I did read about it was a YouTube comment where they were saying that some people they're getting fusion, cold fusion, but the amount of energy they have to use to do it exceeds the reason for doing it in the first place.
Well, that's one of the main criticisms, that even if you were getting any nuclear energy out, first you have to show that you are getting nuclear energy out. And there are cases where you can get it. There's a muon catalyzed cold fusion where you take an atom and you replace the electrons, which are very light, with muons, which are like heavy electrons. And so the size of the atom gets smaller, because the orbital size with muons is much smaller. And with muons, you can get a few cases where the nuclei can get close enough together to overcome the Coulomb barrier and fuse. But the problem is that the amount of energy that it takes to generate the muons, and they're very short-lived, is more than the energy you get out. So although you really are getting some fusion, you are getting the decay products, you're still ending up spending more energy to create the damn muons than you're getting out in the net output. And they show that the ratio between input and output is so far apart that it's unrealistic. You're just never going to be practical. It's not that you can't get low energy fusion. You can, but not in a way that's practical. It's like quantum tunneling. You can get particles to tunnel, but it's so infrequent, so rare, from terms of quantum mechanical probability, that yes, you can build a quantum tunneling semiconductor, and you get tiny little signals that quantum tunnel through a barrier, but you're only getting a little bit of information, not power. You're not getting an enormous amount of power. You're just getting a little bit of occasional information transfer. But it's expensive.
So they're looking for attention by delving into controversy.
Well, they basically are keeping their livelihood alive as long as possible, even though it's dead in the water. The same thing happened. Was it Max Planck who says physics advances one funeral at a time? Well, pseudoscience dies one funeral at a time. So you have the diehards, and then pseudoscience, and eventually the diehards die, and pseudoscience dies one funeral at a time.
When the debate was raging about climate change all through the early part of the century, the first decade and a half, then a lot of scientists, a lot of politicians were saying that, okay, these scientists have this consensus, but consensus does not equal causation. And you'd hear this.
It's not about consensus.
Yeah, it's just belief. It's just,
it was,
But
but
they
parrot
believe
fashion.
in.
No, listen. I heard this parrot fashion from all the politicians,
You heard the what?
Consensus does not equal causality
Yes.
in climate science, and that this was repeated by the politicians, parrot fashion, over and over again on all the major news corporations. But the scientists who were having the consensus were saying this is an important consensus, and it's a huge consensus.
Right.
Over.
Yeah, and the mathematics works out. And the thing is that the mathematics works out. First of all, how do you know that the mathematics is correct? Well, there are people who are experts in analyzing mathematics and can tell a correct calculation from one that's got mistakes in it. The average person has no way to know that there's mistakes.
There's science climate researchers who learned how to read a thermometer.
Yeah.
And record the readings over the decades.
I mean, consider the ideal gas law. The ideal gas law, you assume that the gas particles are infinitesimally small and have a mass and a motion. Okay. And if you put them in motion, even if you know the exact movement of any one particle, that doesn't tell you the other ones. They have the same statistical behavior, and the mean kinetic energy, 1/2 mv squared, mean is KT, the temperature. The temperature is the statistic that's the mean kinetic energy of any one molecule.
You've got
but that doesn't mean that you know you can't do a simultaneous equation with Avogadro's number of molecules in a mole of gas.
You can have a probability cutoff point.
Right, and you can even get the distribution around the means. You get the black body radiation shape of the distribution, so you can get the statistics. But no one molecule is exactly equal to the mean or one standard deviation from the mean.
You're splitting hairs. So
the point is that statistics goes all the way back to the ideal gas law. They do the same thing in quantum mechanics. You can have a model of quarks, but you can only give the statistical ensemble. Not that you can't track any one quark, but you still get you still get the temperature, you still get the pressure, you still get the volume, you still get the ideal gas law, even though you can't identify any one member of the population. And that notion that you can get a lot out of statistics and Bayes' rule and all that kind of stuff, that's graduate level mathematics. Most people don't. If you say Bayes' rule, they'll say, I've never even heard of it. I don't know what it is. And if they try to figure out what it is, the math is over their head.
I've got no idea when it comes to maths.
The Monty Hall problem is a classical kindergarten example of Bayes' inference, and that Monty Hall opens the door with the goat behind it, and does that change your choice of which other door to choose? And the mathematics to show that is Bayes' theorem, and yet very few people could understand that, including a lot of physicists.
In fact, they didn't for quite a while.
Yeah, that persisted for probably a decade before I think Marilyn Vos Savant in Parade magazine finally woke enough people up that yes, you can apply Bayes' rule. Yes, Bayes' rule is mathematically sound, and yes, you should change your prediction, your choice of door. And here's why. And that's trivial. I mean, that's an elementary example of Bayes' theorem. That was really hard for the general public and even people who had degrees in physics. Go ahead, Sam.
So I think the initial discussion about this was debunking cold fusion. And this involved, I guess, looking at the facts, looking at the calculations, understanding the theory, trying to figure out why people wanted to believe something that was shown to be not true. So I think that was interesting. I think that there's other cases that are arising constantly. I mean, that's exactly why I wanted to pursue these kind of topics on Sundays.
Yeah. And here's the problem. You see how hard it is with Bayes' theorem, with the Monty Hall problem. You see how hard it is with Bell's theorem in quantum mechanics. You see how hard it is with cold fusion. And these are stories which the general public knows about. If it's that hard in those stories which persist with misconceptions for decades, imagine when you get to these less well understood examples. And this is why science education and debunking of pseudoscience turns out to be so bloody hard.
Well, when it's near enough, close enough, it's important. The math's got to be right when you're in space, right? Because a mistake when you're orbiting in space can mean death for the whole crew.
They landed a
So-
man on the moon with Newtonian classical gravitational dynamics. They did not have to
manual
use
calculations.
gravitation. They did not have to use Einstein to land a man on the moon. Now, when you want to hit the asteroid, then you need a gravitational, correction. When you want to do GPS, now you need it, because now the error, if you don't do it, it's a lost cause. But the moon was big enough that you didn't need it. Go ahead,
All right, Barry,
Sam.
let me ask you, since you brought up this whole asteroid collision business, okay?
Mhm.
One approach to alter the path of an asteroid is to slam into it.
Right.
I was wondering what the difference is in the total effect. If rather than slamming into it with some mass, you had enough fuel that you could still burn for some time and just direct that burn so that you could affect the orbit or the path sufficiently, and which would actually give you a bigger deviation in the path.
I actually wrote that case up. Well, I went to take a course in the summer writing workshop on writing science essays, and I chose that exact situation as the basis for an essay. And so I had an asteroid that's coming into the Earth, and it's going to hit the Earth, and CNN is covering this story, and they send Christiane Amanpour out to ride the asteroid to be the field reporter for this big event. And who's the other guy who does the Pentagon? I forget the other guy's name. He's back on the Earth, and they're communicating as this thing is coming in. And of course, this is going to be Christiane Amanpour's last big thing, because it's going to hit the Earth. And if you've ever seen Christiane Amanpour, she has her flak jacket on, her flyaway hair, and all this kind of stuff. And the point is that she has the makeup kit that she never uses, including the hairspray that she never uses. And I say, oh, she has a can of hairspray. Can you fire the can of hairspray in some direction to steer the asteroid away from hitting the Earth? And if so, which direction? Do you spray it forward to slow down, backward to speed up, or sideways? And of course, the answer is
orthogonal to the current path. That's
exactly
the intuitive way, right?
Exactly. You would spray it sideways to steer sideways. So if you do it soon enough, even though you're headed towards the Earth, if you could slightly change your angle by steering sideways soon enough, by enough amount, you can skirt the Earth. And that was the basis for this study. And I wrote it up, and when I read it at the class, the rest of the people were just astonished by this little science essay, and it's up on my blog. You can read it. It's up on my blog. And it's all about, using your knowledge of science and mathematics to calculate exactly what you're talking about. How much side thrust would you need to put on an size at a given distance, at a given speed, to just steer around and avoid the collision? This is like driving a car and steering around an obstacle. How far do you have to turn the wheel, and how soon, so that by the time you reach the position, you're astride it instead of head on to it.
By the way, there's a key tenet of Tai Chi in there.
Right. Yeah. The minimum correction to avoid a collision, to get a grazing near miss.
Okay, so that was roughly the question I asked you, but not exactly. The question was, let's say I've got 100-kilogram missile, okay,
Right.
targeted at the asteroid, right?
Right.
Versus a shell of a missile carrying maybe 900 milligrams of fuel and 100 milligrams of something that could burn it.
Yeah.
Right? So I guess, oh wait, one thing I'm forgetting is, first I have to land gently before I can actually do that. And that might actually take up more energy.
It depends on whether you slow it. If you have to slow down to avoid a plastic collision, a material disrupting collision,
Right.
if you have to slow down, then you have to burn your fuel to avoid a plastic. If you could do an elastic collision, like billiard balls, then you could just slam into it, didn't matter. But if you can't do,
or you don't have to slam into it, you just have to catch it in a net. Right?
Exactly. Yeah, right.
It-
So if you can
catch it in a net and
Right.
then redirect.
if you can do an elastic collision where you don't deform the material, because when they hit this thing, there was a certain amount of momentum that went into it, and there was a certain amount of ejecta, debris. And so and you couldn't predict that because that was going to be unpredictable because it wasn't a billiard ball collision, it was a plastic collision, a splat. But if you can get yourself all the way back to a perfectly elastic collision where you're not plasticizing the material, then you're not wasting any fuel.
Okay. So this is related. It may not sound related, but let me ask the follow-up question. Okay. Remember 30, 40 years ago, Reagan was in his last few years, initiated a program called Star Wars.
Yeah.
It was a missile defense system, right? So he was going to send what 100 billion marbles or whatever into space. Okay. And if a rocket or a missile were being sent someplace towards an American city, basically send these swarms of marbles at this missile, and you say, well, most of them would miss, but a few of them would hit. Basically, that was the premise, right? So my question was, if that really were, how come we're not still hearing about it today? Okay, so that was probably sold under bad calculations or
It
bad
was Edward
design.
Teller. Edward Teller sold Reagan on Star Wars.
So the question would be, if it really were good, okay, then number one, we'd have to have some pretty sophisticated guidance and control systems on these marbles, okay? And we'd have to know that they're going to be up there for some number of years to be effective.
Yeah.
And their fuel is still going to be good, and our communication systems are still going to be good, and they're going to be fast enough, and we can intercept them at the right time of the apex of their paths, et cetera, et cetera, et cetera. So that's what I'm thinking is, if you take a look at all these claims like cold fusion, I think Star Wars feels like it's in that category.
It is.
That it's in
Now,
the
laser
to be
laser
true.
weapons would make more sense because you can send a laser beam a lot more readily from more positions on the ground or in space, and you could sort of converge with a bunch of laser beams without material. And if you could get enough energy in the lasers, so that would make, and I think the laser weapons becomes the successor to the material, lobbing kinetic material. So kinetics gives way to lasers in terms of the practicality and the efficiency and the reliability. Now the problem is, can you build enough powerful lasers without causing damage? Because you hit an airplane that's in the path of the laser, you wouldn't want to do that. So there's all these secondary effects. But yeah, I think basically kinetic weapons give way to energy weapons like lasers.
But anyway, I'm just trying to look for your conclusion and your understanding of the design principles behind Star Wars, and to see whether or not there was actually a there, or it was just sold just to spend some money.
Well, with Edward Teller,
I don't hear about it.
Yeah, I mean, Edward Teller was, it's probably not fair to call him a psychopath, but but he wasn't really thinking in terms of the biggest picture. He was thinking in too narrow of a perspective from the point of view of pure physics. I mean, after all, he was the father of the hydrogen bomb. And by the way, this guy, Richard Garwin, who was on 60 Minutes on cold fusion, wasn't the father of the hydrogen bomb, but he was actually part of the design of it. So he was working for Teller. But in this story, where they say the one experiment with hydrogen that worked, unfortunately, he said the experiment, he says his experiment with the hydrogen bomb worked, sadly.
So can the laser beam, Earth-based laser beam, be powerful enough? And if you had a laser beam on a rocket, could you put one heavy enough on a rocket to be effective?
Well, that's the question. How much material do you need to make a laser that carries enough power to convert all that power into photons, to do the job? And that's an engineering problem, because you've got a bunch of trade-offs between storing the power to drive it, because it's probably got to be electrical power. I don't think you can use fuel to make, to convert fuel to photons is not very efficient. And then you got to get the mass of that up into space, so that's a big amount of energy. And then you got it's in motion, so you have all these engineering trade-offs, and that's a mess.
What color laser beam has the greatest energy?
The highest frequency.
Yeah.
I mean, this is the energy of a photon goes linearly with the frequency, the color of the photon.
Green or blue?
There's more energy in ultraviolet and less energy in infrared and less energy in radio waves and more energy in gamma waves. This is fundamental, quantum science. The amount of energy in a photon of a given frequency, it's Planck's law. HF is the energy of a photon of frequency F.
Yeah.
Go ahead, Josh.
I was just going to share before we start shooting lasers at asteroids. Well, what Sam's question I think is really pertinent is what happened to Star Wars? And I just posted a link that says what happened to the missing $2.3 trillion that Donald Rumsfeld announced right before 9/11. It was all in the news a couple days right
the
before.
defense contractors burn up all of that money, spinning their wheels and not producing a viable weapon that's affordable and functional and effective.
Or
We
did
build all
they?
these weapon systems that either become obsolete before they're used or never become functional enough to be usable.
Or what did they use that money for? What did they create that we don't know about yet?
Prototypes that didn't look at all the prototypes for contained hot fusion.
No, I think you're missing my point. My point is everything I've ever learned from the government, if the government says they're doing something, look at the opposite of what that is. And that's probably what they're doing. It's the magic trick of like, no child left behind. Okay, every child gets left behind.
Yeah.
There's a missile defense system that's got stations all around the world and outback Australia and all sorts of places. It's a missile defense system in case of nuclear war. So there's been a lot of money.
We eventually built cruise missiles. We eventually built cruise missiles that would cruise just above, the surface of the Earth and steer. And that took a long time to make cruise missiles. You have to ask yourself, how much money was wasted trying designs that didn't work before they got a design that was functional and effective and you could actually build them. And then we shot almost all of them in Afghanistan. Afghanistan started with basically our entire supply of cruise missiles were shot at Afghanistan. And then we still had to go in with boots on the ground anyway for 20 more years.
One of the big tricks was how do you guide them? Because they fly so low.
Right.
They have to guide themselves.
Yeah, you have to have a terrain map because it has to know where it is.
Terrain maps were not very good in those days.
Right. So a lot of them, they got there, but they were far enough off, they didn't hit the target. So now we're using drones, which are a lot smaller and cheaper and have better vision systems. So you went from cruise missiles to drones, but you're still in, which one is the most cost effective, in terms of the technology and the cost and the effective reliability and all that,
Barry, you're not with the government, man. It's not cost effective. It's which one costs the most. It's the opposite. Right. Which one can we get the most?
Yeah. I mean, when I was interviewed for a job at Bell Labs, one of the departments that interviewed me was the department that was doing the prime contracting on the anti-ballistic missile. This is where you're going to shoot a missile and, it's like shooting a bullet at another bullet and hitting them in space. And I went and I listened to the guy pitch this anti-ballistic missile project to me. And in order to explain it, because we're talking about 1968, he picks up a piece of chalk and I'm sitting, on the other side of his desk about 6 feet away, and he lobs this piece of chalk at me, expecting me to do that. And I watched this piece of chalk go by and land on the linoleum floor and smash it a bunch of pieces. And he says, a lot of people miss the chalk. He says, you didn't even try to catch it. And then he gave me this whole spiel anyway. And I said, Mr. Katz, that was his name. I said, I really don't want to build weapon systems. I don't want to spend my intellectual energy and career building a system that I pray will never be used. I want to build something that will be used, like the telephone network. And he says, yeah, I appreciate that. I have a lot of candidates who don't want to build weapon systems that they pray will never be used. But that was a personal value system, okay? But I sat there very politely and watched the chalk go by and land on the floor. And I understood the concept of intercepting a ballistic missile, like catching a ball. But, I didn't want to, expend my professional career doing that. I have plenty of friends who work for the defense contractors and who built weapon systems, avionics systems or whatever, and made good money at it. They bought beautiful houses and, went on nice vacations. And I didn't want that. I didn't want to build a system that I prayed would never be used.
So back then, I don't know if you're familiar with the quality of data back then. Are you familiar with an acronym called DTED, DTED?
DTED,
Yeah,
what does it stand for?
digital terrain elevation data.
Oh, that's what a cruise missile would have to rely on. Yeah, right.
Exactly. It came from our Defense Mapping Agency, DMA. But the problem is, you don't know exactly how good that data is. I mean, I know how good it is, but you
Yeah.
know, that's actually
Right.
It's probably declassified by now.
How,
But
how much?
there was good DTED, and then there was really better DTED. Okay, and
Yeah.
the available DTED was only so good, but the really available good data was much more highly classified.
How does it
But it
map
didn't
into
exist
hitting
for
the
every
target?
location.
Yeah. How does it map into hitting the target versus missing the target versus hitting collateral damage? And you have to work out all of these probabilities and calculations, and it's a bloody mess. And at some point, you got to say, okay, we're going to deploy it, or it's too erratic or too problematic. We're not going to deploy it.
My point being, I think today GPSs use a kind of positioning system that's way better than just DTED. Okay, I think it's actually good down to at least as good as 17 feet now, but it could be even better. Than
Well, you have to
back then, it was nowhere near 17 feet, is what I'm saying.
you have to have timekeeping. For example, GPS is accurate to nanoseconds because a nanosecond is a foot. If you're off by a nanosecond, your position is off by a foot. And if you're driving a car in a lane and you're off by 5 feet, you're in the wrong lane. Or you miss the exit or something. So you had to have clocks that could keep coordinated time, not synchronized time, but coordinated time, because they run at their own speed. So you had to have a time correction, but you had to have coordinated time that was in agreement to, within a few nanoseconds.
You've got
That's a long time.
resolution. Same thing with the time and the resolution is both important. The time and the distance, because in the resolution of distance, you've got a kilometer resolution, meter resolution, and centimeter resolution,
Right.
even
That's
down to millimeter resolution.
That's a nanosecond right there. That distance is 1 nanosecond of light. So if I can't measure time to a nanosecond, that's my error in reckoning position.
Did I tell you, Barry, about the Ono second?
The what second?
The Ono second.
ANO, ANO?
Oh no, oh no.
Oh, no second?
It's
No.
the one, it's the amount of time that elapses after you press the enter button when you send the wrong message to the wrong
Oh, yeah.
person.
Yeah, it's about 500 milliseconds or 200 milliseconds. Oops, I just saw the mistake too late. Go ahead, Josh.
That's why
Oh,
Facebook Messenger has a undo for a few
Thank you.
milliseconds.
Thank you,
But it's
Sam.
not long enough. It needs to be a little longer. It's not quite long enough.
They have it. They just changed it on the iPhone to 15 minutes or something like that.
Yeah, on Gmail, it's less than a second, I think, or maybe about a second. Not fast enough, not slow enough for me.
Yeah. So we've hit on cold fusion, we've hit on Star Wars, but in the middle of talking about Star Wars, Josh brought up these missing trillions of dollars. And by the way, the 2.3 is not the only dollars that are missing. There's like at least 14 trillion, possibly 22 trillion.
I've seen it up to
that are missing over
21.
the
Yeah,
decades, right? It's in the tens
absolutely.
of trillions.
It's a lot.
Tens of trillions, not billions. Okay.
Harry Truman warned us about this. Yep.
Which is time and energy, human time and energy wasted, and materials wasted that could have been used for a better
Not just
purpose.
wasted, stolen.
Yeah, stole. Yes, okay, same story. Not used for good purposes to make the world a better place for everybody. Corruption and all that kind of stuff. So you get the oligarchs and whatnot. And most of the stories are about, this misappropriation and oligarchs and corruption. And that's very depressing. It's literally
true,
quite
we have
depressing.
a reasonably large economy, arguably the largest national economy in the world. But if you talk about tens of trillions, that's a big dent in that.
Oh, yeah.
Over decades.
Divided by the population with 300 million people, get the per capita number. That's really, how much is that per person? Divide by 330
Computer,
million.
23 trillion divided by 300 million.
23 trillion divided by 300 million is approximately 76,666.6667.
Yeah, you're talking about 100,000 as a year's salary. That's about a year's salary for the
More
average.
than that for the average person.
Yeah, you're talking about close to 100. I think a middle-class family income is about $100,000 a year. A good middle-class income per family. Somewhere.
If you did that real number and then also account for inflation,
Yeah.
I think it's ridiculous. It is
We're
crazy.
probably closer up
What's
to
your point,
100,000.
Sam?
It's like every
I know-
person wasting
I know
a
you
year
have
of their life.
So what's your point, Sam? I'm
My
listening.
point is that transparency is necessary to get rid of all this crap, all this corruption, all this abuse, all this graft, all this power mongering.
And not just transparency, but in being able to reckon what you can see through the transparent medium. Because I can present all kinds of information that is just so, it just snows people and so overwhelming that they can't process it, they can't interpret it. And that's the other half of it. You can present stuff and people go, that's over my head.
And yet, we have this fraud of accountability, of oversight
Yep.
on this budget.
Yeah. So if the ethicist in the White House says you can't do that, Mr. President, that's unethical, and the president says, well, then you're fired, to the ethicist, that's the Alexander Vindman story.
Walter
right?
Schaub.
Walter Schaub and Vindman. So the people who are ethical get marginalized. Yeah, you get the reality winner who gets a year in jail.
Can I ask
Okay.
a question? Go ahead, Sam.
No, I was about to switch topics, but go ahead first.
My question is, moving forward, a lot of these things are justified by keeping the world's peace, by keeping our dollar strong, by creating a world where the oil is representing the dollar in 1973. Thus, we have to keep the oil going, blah, blah, blah. In other words, national security and international security is the justification. Is there a way to share the responsibility of policing the world with the rest of the world? Does it always have to fall under one nation's ability to do that, or can it be shared? Can there be a shared police force is my question.
In my view, it cannot be under the control of any nation or multiple sets of nations. It has to be an independent agency, which is why I think if you leave it for any organization to police themselves, i.e., some kind of a internal affairs group of a police department, how effective is that going to be? And it's going to be subject to all the political power struggles within that organization. Same thing with governments, same thing with NGOs. You got to have some external, and that's what the press was supposed to be. Journalism was supposed to be. They're supposed to have access in order to inform the public, the citizenry, so that we could make good decisions. But once you eliminate their right to access information, you get rid of FOIA, you get rid of, even they're kicked out of White House meetings, for example, during meetings with Russian diplomats.
Yeah.
Once you eliminate the power, the transparency that the journalistic profession gives you, then government can do whatever the crap it wants. And that's what we've seen. So it has to be an external agency, in my view. It cannot be, oh, well, we'll police ourselves and we'll tell you what we did wrong. How often does that actually work?
So would that be a joint of two agencies independent, which is a journalistic branch and a police branch and maybe a few other branches, kind of like we have the United States government set up in different branches? Would there be checks and balances that could happen in order to create an force?
So in my view, it doesn't have to be that way. If you're creating a government, then I think the answer is yes. But if you're first trying to go after transparency, you can forget the enforcement till later. You first have to get transparency. Then you can figure out what you want to do about enforcement. But that transparency, enables whatever else you can do. Without it, then there's nothing else you can do. But that transparency requires access. And it requires, those with information to be accountable. So even today, if I file an FOIA request for something, okay, I don't know whether or not that was adequately satisfied. Only somebody in government says, oh, yes, I gave you everything. No, the fuck they didn't. Okay, look at what Trump did with all of his files.
Right.
No,
I gave them all back. I gave them all back. Take my word for it.
So even with an external profession of journalism and news reporting, you're not assured all you can do is triangulate on multiple different paths of reasoning, but that's difficult. The simple thing is somebody goes and says, okay, did you do X, Y, Z? Yes, sir, let me write that down here. It's a news article. But the good ones, you know, like the guys that expose Watergate and others, they look at multiple different angles. They look at multiple different sources. They look at tracing, you know, paths of people, documents, vehicles, money, you know, they have to put the whole story together.
Right.
That is actually an intelligence function.
Yeah.
People, very few people understand an intelligence function, but that is intelligence. Okay, understanding what happens based on multiple different sets of data and multiple apparently contradictory sources of data. You got to figure out what's true and what's not. So you got to go second order, third order, fourth order effects. And that is difficult and that is not easy. And therefore, most people don't do it. Certainly, most traditional journalists don't do it. It has to be at the highest levels of the profession before they actually were able to do that.
Right.
That's why Woodward and Bernstein wrote books about how to do this.
Right.
And what they did. You know, you got to meet people in parking lots late at night, at midnight, you know, in order to figure out what's going on. You
Deep
can't just
throat.
say, oh, sir, what did you do? And then just write that down as a news article. That's not news. You know, that's PR for whoever you're talking to. Sorry if you go on a rant, but no, the answer is you need an independent agency and you still have to triangulate and you have to do hard work. And you have to reason about that information that you're being given. You can't just spew it back. Sorry, go ahead, Alex.
We need a organization, global organization of ethics that has teeth. In other words, not a toothless tiger like the United Nations, Human Rights Watch. We need one with teeth, and that means one that, like you say, having access to the information that's usually denied by Secret Service agents and FBI and internal documents that are classified and super secret. So in order to overcome that sort of thing, you need to look at the percentage of people in the world who want this information disclosed, and that's a high percentage. You know, how many people want corruption to continue and trillions of dollars to be wasted and misused? A lot of it, 99%. There's only a small percent of people who are happy with the situation. They're the ones in the top 1% making a profit from selling weapons and arms. But the politics is you've got to protect the nation. If you're a politician, you're working for the people who voted you in, and you've got to protect the nation. And there's wars overseas in other countries that have resources that you need for the economy. So it's a dirty swamp of corruption, and 99% of the people want an effective solution that has an ethical dimension and is global in nature, global in power, and global in authority. So how do you avoid those people becoming corrupt and taking handouts? They've got to be fairly special people, I think, diplomats with statesmanship and backup mechanisms to watch what they're doing. It's got to be all open. No secrets. Over. Sam?
So I think we've seen that when governments themselves have to fund or provide resources for these extra national agencies like the United Nations, politics always enters, right? We say, oh, how come we provide the bulk of the budget? You know, therefore we should get our say. And, you know, small countries like Swaziland may not be able to have the same influence, but, you know, they're still, are they? Maybe I should verify this first, but assuming they're still considered a full member, what does a full membership mean if they're providing this much budget and US is providing this much budget? Or what does it mean when we actually withhold budgets in order to drive the agenda? So that's why I think it's got to be an external agency. It can't be funded by the governments themselves. But as you say, very few people care enough. Can you imagine an ACLU that was national in scope? I'm sorry, global in scope? Or some kind of a, you know, Office of Ethics back when it used to exist, or any kind of a ombudsman kind of organization, right? Ombudsman organizations are typically the least well-funded organization. They have one puppet in place, and now the organization says, yeah, we deal with that. You know, how often do you actually get action out of them? I don't know. I'm still ranting today. To be honest.
Oh, you just made me think of something, Sam. The crowdsourcing of legal
That's right.
of writing actual laws. And then the one thing I've heard quite a bit is it's easy to get a law into the books. It's hard to get a law out of the books. So on top of your transparency, if there's laws that are allowing for the corruption to happen, if those laws can be changed, that's the hard part, I think. Especially like you're
Pork.
saying, a global ACL.
Pork barrel
LU.
politics.
Yep.
You
But
know?
I'm saying if we crowdsource it and everyone was aware of the laws that are helping the corruption, and we could crowdsource the rewriting of those laws so that it's not just up to one government to do that, it's up to all governments to do that and agree. And so all the citizens of all the places help write those laws. That would be awesome. But I'm that's never going to happen, but that would be cool.
Hence global sim, which is what I've been trying to say since 2009. But that's
Tell me about
patting
global
myself on
sim.
the back.
Pat
Okay.
yourself more. What are you saying about global sim?
Okay, as a invitation, and since you've invited me to do so, it's the
If Barry and
ability.
Alex are interested, yeah. Are you guys
It's
down?
the ability for all of us to share data, not just information, facts, but then models, heuristics, systems, subsystems, and basically be able to say what if on a micro as well as macro level. So that we're not just arguing just because I'm louder than you, or I'm richer than you, or I'm taller than you, or I'm whiter than you, or whatever. Okay. It's that my reasoning, my model, my facts, my subsystems, my theory, my principles, my experiments show that if we do the following, then the following outcomes are likely. This by that percent, that by that percent, that by this percent, and that these models are composable. So you can have your models, Barry can have his models, Alice can have his models. I can then take any 2 or 3 or more combinations of models and then tweak them, adjust them, add my own reasoning so that we can actually try and figure out what is likely to happen with a series of investments or decisions or actions or plans or programs or whatever, okay? And that if we do this, so that anybody can do this, from the lowest level reasoning to the highest, then the merits of these models will themselves cause these models to impinge on each other's attention. And if we can do this to make decisions, first on a local, but then on a greater level, and then on a national, then international level, that's the way we ought to be making decisions. And that's what global sim is all about. End of rant.
I was going to say that sounds exactly like what Andrew Yang was talking about. I don't know if you ever heard him speak.
I was trying to define this since 2009.
Yeah, he's right there with you. He's a big Lawrence Lessig fan. And one of the things that, he did before he ran was speak with Lawrence Lessig and take some of his platforms.
Lawrence
the
Lessig
idea-
is not the best advisor on political strategy, by the way. Notice his
No,
own
and neither,
campaign.
not only is he terrible at political strategy, his political strategist is terrible at political strategy, meaning the guy that Andrew Yang hired for his political strategy was terrible. But the idea of putting PowerPoint into the State of the Union address, I thought was a very powerful concept. Like you're talking about, let's let the citizens see the charts and see what's actually like. Let's pull up an Excel spreadsheet. Let's look
Ross
at these
Perot
things.
did that way before, gang.
I
remember
love Ross
Perot?
Perot. Yeah,
You know?
I was going to vote
Remember
for
his
Ross
charts?
Perot. I love this chart. So let me show you something. Let me show you something. I loved it.
His pointer?
I think we need more Ross Perot. That's my point. Is what you're saying is he ran on the platform of a math president, but the average person went, weed? I don't know. We want weed. And
Yeah,
that's why
what I'm
we have
saying.
Biden.
You cannot leave important decisions like national investment up to stupid people.
Well, you got
Okay.
to educate them first, right?
That's right. But the system, the decades of dumbing down our educational system has created the population we got right now. Okay.
I agree.
They'll be
100%.
happy to give $100 million to Brett Favre, okay, who's basically a criminal, and yet they'll kick him out of the league when he takes a knee. That's Colin Kaepernick. That's the kind of people we got right now. Okay.
Well,
We got people, football game watchers, okay, who don't value ethics, Alex, okay, take into account this Favre versus Kaepernick distinction, and who just want to be entertained. They don't care about truth. They don't care about rights. They don't care about lives. They just want their Sunday football. And they'll spend their $100 a ticket, but they're not going to give $100 to Colin Kaepernick or Black Lives Matter. And yet they'll buy 16 tickets in 1 year, and then they'll drum out Kaepernick from the league. This is the kind of citizenry and population we got today.
It's
And
not
we're letting them vote.
sustainable.
We're letting them vote.
Yeah, it's not
There ought to be
sustainable.
criteria on your right to vote
And reproduce.
and reproduce.
Ask Darwin, what's the
I don't know why I'm
likely-
ranting so much today. I apologize for that, but I am
What's-
ranting today. I see that.
What,
Yeah.
what's the future of an unsustainable system? Ask Darwin, what's the future of an unsustainable system?
Pretty bleak.
Extinction.
Gonna collapse. It's gonna collapse
It's
early.
bleak, very bleak indeed. And you know,
Yeah.
Biden pardoned all those people with minor possession charges of marijuana.
Yeah,
But
just yesterday.
none of them are getting out of jail.
Because that's not what they're in jail for currently.
Yeah, well, they pardoned them, that's fine, but none of them are getting out of jail because most of them are in jail for something more serious.
Right. Yeah, we created an unsustainable system. We haven't seen our way clear to create a sustainable system. We've been talking about it, but we haven't figured it out how to implement it. By the way, the calculus of ethics is easily an order of magnitude more challenging than the calculus of Isaac Newton.
You're saying that ethics is more difficult than plain physics.
Absolutely, by at least an
Yeah.
order of magnitude. I've done both. I can tell you that it was much easier to do Newtonian calculus than to do ethical calculus.
Well, of course, you know, you can tell if a ball's going to fall, you can tell what's the weight of the ball and the trajectory,
Yeah.
because you know where the magnet is.
It's much
You know,
more predictable.
But when you've got to make a decision about which path somebody's going to take in their political career, that's up in the air, isn't it?
Much more uncertainty and much harder to work out the ethical best practice. If I want to know what angle and what speed should I throw a ball, that's an easy problem. That's cannonball shooting. But try to figure out the ethical best practice in politics. Good luck. It's a huge
Well, wait.
decision space.
Let's at least figure out what the counterpart, the equivalent is of the ball falling to the ground. Okay, if that's what you're saying is a simple problem in physics, then there are simple problems in ethics, right?
Yeah.
I mean, I could say if I've got an axe and there's a friend of mine, am I going to hit this person on the head? No, that's a simple case in ethics. Just like, ball falling is a simple case of physics.
Yeah.
And from there, it gets more and more complex. Okay. So
I'll give you
don't
a
confuse
hard.
politics and governance with balls falling. Okay,
Yeah.
that's all I'm saying.
I'll give you a hard problem in physics. Feynman says we have very nice mathematical models for how quarks and gluons behave, but we can't compute them because you got to do it practically an infinite number of simultaneous equations. Even though we have the equations, we can't compute simultaneous solution to a jillion interacting particles. As soon as you got 3 or more interacting particles, the mathematics goes to hell in a handbasket.
When you've only got one particle or just a few particles that are doing the same thing, they're easy to predict because they don't have to avoid tax. They're not trying to get out of some payment of some kind with the corruption. So there's no ethics in physics.
3 gravitating bodies, the tiniest error in the position of just one of the 3 bodies, and you're into mathematical chaos in Newtonian gravitational dynamics. 3 bodies you can't compute. Joshua?
I'm just thinking about, I've been thinking about that problem for a long time about computing and predicting, but maybe it's not a question of knowing what's going to happen as opposed to a question of emerging. And the example I use is a certain amount of ants are following a line and a trail in an ant colony, but there's 5% of them that are emerging. So they're going off the trail to create that emergent property. So what if you created more emergence and allowed for the understanding of more possibilities, or just to even understand emergence is a better idea than understanding predictivity,
Right.
if that's even a word.
Well, that's what evolution is about. It's merging things that had not been seen before. There was no, the first instance of a new pattern is, it's an anomaly, and then it might become a recurring pattern, but there's always the first instance of an emerging pattern, and those are not, you can't predict them because they're not in the existing model, and they emerge out of nowhere. Now, maybe once they have emerged, you can go back and see why that they emerged out of quote nowhere, and it wasn't nowhere. It's just that your prior model was inadequate. It was incomplete. But this is a perpetual problem in complex systems, that new patterns emerge, and then you can say, oh, now I see where they came from, but I didn't see them coming.
Yeah, I'm just saying, if you just change your line of thinking and your framework and the narrative of the problem of not being able to predict, as opposed to embracing the emergence and embracing the idea of not knowing, like just even in conversations with other people, the people that say you're wrong are not embracing the emergent possibility of the conversation. They're shutting down the conversation.
That's where I will turn around and say to Jed Rothwell, you're trying to shut me down, but you've overlooked a fundamental principle of electrical circuit theory, which is well known to a sophomore, but you've pretended it doesn't exist. And now he tries to dismiss me, and I come back with college level science and mathematics and technology. Is that a worthwhile thing to do? Maybe he's the only one who's throwing mud at me. Maybe everybody else is just not even bothering to attend. And he's not going to change his mind. He's not going to change his practices. He's going to continue to hawk cold fusion until his dying day.
You can argue with these people, but you've got to remember that if you continue doing the same thing over and over, expecting a different result to appear, you're bordering on the insanity spectrum.
That's why my audience is not Jed Rothwell. It's anybody else, maybe even Sabine Hofcenter, but at least somebody else who's reading that and saying, oh, that's an interesting perspective that I didn't know about. So maybe there's a third party who's only a silent observer that I'm reaching. And I have no way of knowing that unless they come back and say, oh, that's really an interesting perspective. Sam?
Well, to that point, that's why I explained to Stacy yesterday that yes, at times I do resort to mockery. Okay.
Right.
And sometimes engagement, when it's not possible, is shown to be fruitless. And when it's actually hit a limit, then they don't. When the value of rational discourse or truth is clearly not there, then you got to try something else.
Yeah, and in fact, if you
either
go
you
to my
try
blog,
power, which I know is respected, and therefore we get into a violent fight, or you try comedic power, which is sometimes effective, sometimes not. I'm not saying it's always effective, but you got to try something other than reason when reason hits a wall.
in fact, if you go to my blog, the one where I have the technical analysis, and you put in a search on cold fusion, you'll find that in addition to the technical stuff, there's mockery. There's song parodies and other mockery. And in fact, if you look up the column inches of mockery, which came later, there's more column inches of mockery than the column inches of the technical analysis at the end of the day.
Yep. I think at the end of the day, what I hear everyone saying is it's a belief. If they believe you, Barry, as opposed to the gentleman who's doing bad science, that it comes down to belief. I mean, that was a whole big thing of Yuval Harari writing those books, those 3 books that he wrote, Sapiens, Homo Deus, and 21 Problems for the 21st Century. It all comes down to, I mean, even the money system, we have to believe that the government is telling us how much. Is it 21 trillion? Is it 2.3 trillion? Like, do we believe that we're even in a system that's calculating money? Like it's belief. I just think it all comes down to how the real key question is, how do you form belief systems in a way without manipulation, but with truth and facts?
That's epistemology. How do you know if your beliefs are accurate? And epistemology is the branch of philosophy that addresses that question. Does it answer it? Well, it gives you some tools for thought, but they're not guaranteed.
I understand epistemology as a study of knowledge itself. And I think there's knowledge and belief in that intersection. Again, back to intersection. Where do those intersect? Belief and knowledge.
How do you sort knowledge from erroneous beliefs?
It's
That's
the
one-
truthiness of
misconceptions.
knowledge.
One
Sorry?
important aspect, sorry, Sam,
I was just going to add, it's the truthiness of knowledge, to borrow a Colbertian. I think.
Yeah,
Yeah.
How do you recognize a misconception and discard a misconception in favor of something that's more accurate and makes a better, more accurate prediction that's more reliable? That's really hard to do.
when you look right back, 2-3 centuries ago, some of the things they believed then were just astonishing. And so we think the things we believe today are good. We've got very good reason for believing them. But in a few centuries' time, they'll look back at the things we believe today and they will say, look at that, it's astonishing.
What's sad is this is evidence that a lot of people, I dare may even say most, don't have even a basic introduction to either philosophy or logic or mathematics or science.
Exactly. And that's
And if you're
tragic.
growing up just in the liberal arts without exposure to those 4 domains, arguably it's incomplete.
But you
And
can
yet we
become
let a
very
lot
good
of people
storyteller.
graduate with zero background in those 4 areas.
Right.
If the belief in something is going to have a powerful effect on your life, then believe cool things like, fuck this, I can do it.
It's very hard to find a science journalist who really groks the science, who's a really good journalist who can tell a good story, a good narrative to the general public that doesn't distort the science.
Yep.
Yeah. The facts that come to hand, the facts that were available at the time we wrote the story.
You can write a story that's understandable but misleading. And most general public will prefer a science journalistic story that's understandable and not care the fact that it's misleading and does not jive with the mathematics. They won't know it doesn't jive with the mathematics, and they'll, but I didn't understand the mathematics, but I understood this narrative. Yeah, but the narrative is misleading.
Because the publication funded by Big Pharma.
Because you can't sell a magazine if the audience says, I don't understand these articles. If I understand these articles, you may understand the articles, but they're not really telling you the true story. I see articles in Scientific American which are just bogus, but their great narratives are just wrong. They've thrown away the science in favor of a narrative. Joshua?
I'm just curious, like in my mind, I'm thinking of the Bernie Sanders bottom-up approach. So what if you just tried to get 57 people and just try to educate 57 people and then try to get another group of 57 people, then put those 2 together and see if they can educate another 200, so on and so forth, that each one teach one principle. But it's hard enough to educate 5 people, let alone 57.
Try one. Or
Well,
just
no,
by
there you
educating yourself.
There's a guy down in my unit block who gave me his bicycle the other day. He saw me trying to fix my old bike out the back and he said, I've got a bike you can have. And he gave me this great specialized 21 speed mountain bike. It cost about $700. And I tried to figure out, why did he pick me? And he said, I was looking for someone to give it to. And he said, I chose you. He said, there's too many arseholes around here in the other units, I wouldn't give it to them, or something to that effect. But anyway, I realized something about that, and that is, I've forgotten why I brought that up.
Why did
It's
my
a-
neighbor give me this old obsolete not iPhone, it's just an Android. He gave me this old obsolete Android because anybody else would have thrown it away. I put it back into service. That's why he gave it to me. And anybody else would have said, I don't want it, I'll throw it away.
Yeah,
Uh,
I just was going to say, Alex, I'm trying to start a movement, which is the idea of Feynman explain me this. So when people are talking, they use the Feynman approach, the Richard Feynman technique of explaining. In a little room in Clubhouse, and it started growing. It was actually people were really interested in it because we were breaking down in simple terms really complex things. And then Eric Weinstein came into the room and started disrespecting Richard Feynman. So I called him out on it and said, get the fuck out of here, like Mr. Know-it-all. But the idea of making it sexy and fun to explain the most complicated things in the simplistic terms is a movement that I think is needed. And I think it's exhausting. I mean, I was in a room the other day talking to people trying to talk about biological effects of neuroprocessing and thought. And the minute I said it's biological, they went, no, it's philosophical. And I went, well, I'm trying to say biological. You're stuck on philosophical. I'll give you an hour and a half to have your philosophical argument. And then I'd like to bring up what I was talking about. And I never got to because.
Right.
And that was my fault. I put all the onus on me because I couldn't simply explain it quick enough without the fallacies coming up in philosophy.
Yeah. The nonsense persists. The nonsense keeps coming back. It doesn't die.
Yeah.
Pseudoscience dies one pseudoscientist at a time, one funeral at a time.
Well, I've seen a lot of more people trying to debunk climate change on YouTube, which is odd to see those movies popping up. Maybe YouTube knows I'm trying to solve the problems with my groups and that. So the algorithm's sending me these people that are knocking climate change science.
But YouTube is about views and they make their money on that. And then the people that actually create these YouTube videos make money on that. So it's in the best interest to change the belief system to a more convenient belief that climate change is not real, because that makes you feel good when you wake up in the morning. It's all bullshit. I don't have to worry about it. I can just live my life. It's a lot easier to believe the falsities. Like I've seen so many college professors talk about how truth gets stuck into the history books. And once the pseudoscience is printed as fact, that's what sticks. Once it's printed and that's out there, forget about debunking it because it's too late. Even if you debunk it, I mean, just like we're talking about the $2.3 trillion that was missing from the Pentagon in 2001. If I say that to the average person, they'll call me a conspiracy theorist. That's not true. Even though it's a fact, it's in the news. I can pull up the videos. I even posted it to our chat here. They'll say that that's not true.
Yeah. In science, you don't falsify an hypothesis by declaring it false. You have to show that it's false. You have to falsify it by some effort. You can't just say that's wrong and dismiss it and hand wave it. But look at all the people who just hand wave things away.
But the world doesn't work in science. So I'm saying that is the most effective way to put people in their place. And that's the way the world is working. That's what Trump did to get into the presidency.
Yeah.
Oh yeah, you're stupid. You're ugly. I don't want to listen to you.
I see Sam put his hand up.
Oh, I didn't see that. Sorry.
Is that how Ellen Jones got into trouble?
Well, he just throws things at the wall and hopes one sticks. He's right one out of 100, and then people say, "Oh yeah, he's right."
Yeah. One event does not equal a trend.
Yeah, we see your hand up, Sam.
Well, if we're at a juncture where we could possibly switch topics, I wanted to bring up a question that you had for me last week. You had asked me why I was interested in collective intelligence, and I answered in respect to collaborology, and you asked for the definition of collaborology. So I did find that I had shared this before. I'm going to share this again. I'm putting it into the chat, but at least a couple of places I put, and these have been shared multiple times. And I'll just read one of them just to cut the time for it. It's the theory, principles, practices, tools, lessons, and case studies of scalable, successful collaboration, eventually to planetary impact. And I think I've been pretty consistent on that for a few years now. So I just wanted to go back and note that you had asked a question and I responded, And so it wasn't that it was a dangling point. I just wanted to close that point.
I appreciate it. I did watch the video you sent me a couple weeks back. That was an interview with you, I think 5 years ago, talking about Doug Engelbart, because you sent it to me.
Actually, probably 2013, 9 years ago.
Oh my gosh. Okay. Well, I did watch the whole interview, and I did see the guy push back a little bit on the ideas for scalability.
Mhm.
And I think that from knowing you this long, this is just my own personal thing, and you can tell me I'm wrong, but I think when it comes to scalability, the narrative you have is clear, it's logic, it's sound, but humans aren't clear, logic, and sound. And I think that's the problem.
Oh, fully acknowledged.
Yeah.
The question is, can we overcome that? Can we level up? Or are we going to yet precipitate another extinction evolution event?
I think you have to play the game. I just, from a marketing standpoint, being a marketing guy, you play the game to grab the attention. Then once you have the attention, you switch the game back to your original point and your original beliefs and your core values. I'm saying, but at first, if you don't play that game, then you get no attention. And I see the same thing with Barry. If you wanted Barry to get more attention, you would reach out to the journalists that have a platform or have any kind of audience, even if it's a 400-person audience, and get a conversation with that person on that platform. And I'm just saying that the game is getting really scary because the people with the biggest platform, like on YouTube, is a 24-year-old ignorant kid that does the silliest videos. But if you got on his platform, you would reach over 168 million people. That's a lot of people. I'm complete.
Alex,
You reminded me by bringing that up, and the thing Sam brought up, that what I was talking to about with my neighbour was collaborology. It was I said to him that it takes two. I was talking about the agreement. You know, without an agreement, you're not going anywhere. And I was thinking that to myself. And when I said to him, it takes two to tango. You know, if you want something to happen. And he said to me, no, actually, it takes one. And all the next day, I thought about that. And I thought, is he right? Does it only take one? Or will you need two to have an agreement? And I think you need two to have an agreement. So if you've got an agreement, you've got something powerful and effective to implement. Over.
Go ahead, Sam.
So I'll respond to you before I make my point. Okay? And that is, I think that the normal kind of agreements we talk about between people, yeah, clearly the minimum is two. But there is a sense in which one needs an agreement with oneself. And that's essentially what I see would help prevent hypocrisy. Trump does not agree with himself. Trump just uses whatever's powerful. Reasoning and consistency within himself doesn't seem to be interesting to him, except for the grab for power.
Yeah.
So I do think there's a sense in which, yes, if one was aligned so that your values, your words, your actions, your consequences, your life were all basically reflecting the same set of ideas, that would be one interpretation of agreeing with self. And when they're not in alignment, and you say one thing and do another, typically you're called a hypocrite. So I do think that sense of agreeing with yourself could be meaningful.
I was looking at my bookcase just now to see if I could spot the title of a book on negotiation by Alex Karras called Getting to Yes. Getting to yes turns out to be really hard. You might think that you can negotiate to an agreement relatively straightforward. It ain't straightforward at all. It's really hard to negotiate a consensus or an agreement. Much harder than people would naively think. Go ahead, Joshua.
Oh, I agree. I think Alex had his hand up before me, though. If you have something to say.
I think he just finished.
Okay. Maybe it was still up there, but I don't know, Sam brought up a really good point about agreeing with yourself. And I think that's a huge thing, because I find with clients, I use a software called Proposify, and that allows me to see how long they spent on the document that they're agreeing to and on our contract. And it lets me see which parts of the document they actually read, or at least spent some time viewing on the screen, even if they walked away from the computer. It's not perfectly accurate, but it has some metrics and some feedback for me to know that they just signed it without even reading it. And I think that idea that Sam just proposed is, before you can make agreement with someone else, you've got to really look into, like, it's easy for someone to say yes and not even think about it, as opposed to actually mull it over. Like, I ask my clients, okay, great, you signed it. Now go read it. Like, I know you didn't read it. Don't even pretend you read it. I might need the money. I might need the job. We might need to get going because of time constraints and discovery process. But I need them to read that document, because that's going to be a problem later on. And how you get someone to agree with themselves before you can scale, I think that's the issue that needs to be solved before you make collaborations or collaborology, is how you understand how that person has mulled over that agreement, so that they truly are agreeing to something they believe in, not something they don't. I'm complete.
So to that very point, even when I first introduced the idea, I said this ain't for everybody. Don't try this at home. I was only looking for maybe 300, maybe 3,000 people in the entire world. But I believe that, you know, if we get to 30,000, that will be sufficient. That's why I'm starting there. I know that most people will not do this. By doing this, I'm talking about this internal agreement, this internal alignment of your values, your voice, your thoughts, your actions, your consequences. So I'm not expecting everybody do this. I'm expecting very few people do this. But if I can just hit 3 or 30 or 300, or hopefully 3,000, and then 30,000, I think the world will turn. Those are sufficient numbers, in my view.
And if not, the world will die.
Yeah,
We'll either
I've heard
advance or go stasis or die.
Just to help out, Sam, and this is just my thinking, is I heard those numbers by you many times, but what I don't see is, like, the question is not will it scale, the question is how will it scale, and can you show that map of how it scales? Because the numbers you just gave me, there's a huge jump between 30 or 30,000 or 3 and 30. There's huge gaps. So, like, in any marketing plan, you need to know, what are we going to do when we get to 250? What are we going to do when we get to 12? What are we going to do when we get to 56? What are we going to do at these different junction points? And what is the difference between Collaborology at 70 people and at 1,700 people? I mean, there's huge points of perturbation. And I think without knowing that, or at least if it's uncalculable, start at the smallest level. I said the same thing to Doug when him and Fabian were trying to build this network, and they asked for some help with their database, and they're talking about scaling it to millions of people. I said, why don't you just try 112? Get 112 people to sign up, and then look at that. And I do the same with corporations and businesses. There's real changes in dynamics when you double in size. And I've experienced that in companies. I got a chance to, go from the 5 people that started the company to 900 people in less than a year. And the challenges that happen in between, since we didn't take care of them, 3 years later, it became a huge human resource problem. We literally had to hire the human resource manager from Texas Instruments to come in and fix our problem. And he hated us. He couldn't stay. He's like, are you kidding me? The way you run this company, I'm supposed to run human resources. You guys are idiots. And then we had to kick him out of there because he didn't, go with our culture, because it was moving so fast that we couldn't manage the humans. And I'm saying, if you don't have a plan for the 6 people, let alone the 3 people, in other words, I know you, Sam, well enough to know that 2 people that know, like, care about you, and do requests for comments and work in the way that you like to work. And those 3 people should love and believe in Collaborology the way you do, at the same value point where they believe in it so much that they're willing to spend the rest of their life on it and willing to show up every week. And if those two other people aren't as committed as you are, then it's going to be very difficult. Like, to me, I think it's about commitment of friendship and commitment of belief, and that intersection between the two, and the communication enough to know when life changes, is there someone that can replace that person? Meaning, you don't leave your friends high and dry. If you say you're going to help them move, you don't just say, oh, no, sorry, something came up. You at least send another friend over, or you pay for a mover or something, you know, if you're a good friend. That's just my value belief. I hope that sinks in.
Noted. Actually, I do think that you have identified a number of obstacles to this that have yet to be able to fully address.
And just what you do with those people, because I think another big obstacle that I've found, at least trying to start companies or mission statements or projects, is that fun. Like, if people think it's going to be fun, they're going to show up. And the fun, you know, they tried to do that in the tech world, and they made like ping pong tables and this and that. But I think the real fun is that innate feeling of wanting to solve a challenge that's so fun to those people, you know, like having a mission statement and belief. It's not the fun that you have at work, it's the fun you have doing the work, if that makes sense.
Yeah. How about getting people involved in the possibility of having fun by undertaking a project agreement where they make a commitment to the agreement? They simple commitment to the agreement, because of the possibility down the line that we could have a lot of fun, enormous amount of fun.
Yeah, and I think, you know, Doug's onto something with the values, because if those values go away, then you're screwed. Meaning, if people don't feel valued as a human being in that project, then all that humanness arrives, if you will. I'm gonna call it, instead of truthiness, humanness.
Can you add two other items to this triangle that has unity at the top, and there's two other points on the triangle that need two words to go down there? So these three elements form a values system for people to use on their token. You know, it's a triangular emblem, or a triangular, what do you call it, thing you wear around your neck, a totem, a brooch, or a node object with three corners. So you've got, you know, in the AA 12 traditions, you've got spiritual, mental, and physical that represents the sphere, the three-sided sphere, or the Trinity, if you like. But if you've got one to develop a concept of unity and trust with people in a collaboration, you need unity at the top, obviously, and you need two other things. So what are those two other things you need? Collaboration, unity, and what else?
Well, I think you said trust. I would put that as number one.
Values, the three values. Trust is a value, yeah. Trust is a value. Unity is a value. Collaboration is a value.
How about the feeling aspect of it? Because it's not comprehensible, it's not calculable, but that feeling of being valued, that feeling of, I mean, that maybe I'm just too touchy-feely for people. I don't know.
The feeling comes with the formulation, because the feeling is like the thing you get that is the bigger than the sum of its parts. How many times have I mentioned that in the last 6 months? Something that's bigger than the sum of its parts is something that evolves because the principles were there on the foundation. The trust, the unity, and the collaboration. Those three things were there, the basic three principles or values. They are what establishes that thing you mentioned, that feeling of being worthwhile, the feeling of being excited about it because of the fun that's going to come down the line. It's coming down the line.
I think Sam is next.
I was about to make another left turn, if it's okay. If
Yeah, we only have 15 minutes, so yeah.
Okay. I did post another thing, and this is again on my campaign to sort of really look and reason at common beliefs, and religion, of course, being a common belief, falls into this quite often. So tune out if religion turns you off, but I'm about to share another meme and just go over this, the bottle of milk delusion. You saw me post this before, okay? And let me see if I can actually share my screen now, just real quick. And I'll just do it for a few seconds, okay? And that's this bottle of milk delusion. When people pray to God, and they say God, you know, says yes if the thing happens. God said no if the thing doesn't happen. God said wait and see if the thing might happen later. And yet we celebrate and say hallelujah because God answered my prayer. And then if you take a look at the right, and you know, substitute whatever you want for this bottle of milk and go through the same communication sequence, the same event sequence, and say, okay, so what really is the difference here? There's all kinds of rationalization and justification for this item called God that you could still do to anything. You could do it to Beelzebub, you could do it to Zoroaster, you could do it to a bottle of milk, you could do it to a goat.
Hamburger.
Or a flying spaghetti monster. So I do want to raise these, not because I think it's an absolute, but I'm posing it and saying, if you think there's a fallacy here, I'd like to see it. I'd like to hear it. Okay. So I wanted to go on record with that since I posted it this week. Over.
You know, when I watch these guys solve logic puzzles like the Sudoku class puzzles, one of the guys does pray. He prays to his own brain. He says, come on, neural network, come on, brain, get in gear. You know, what am I not seeing? He actually calls upon his, you know, his brain or his neural network to you know, to do the job. And sometimes the brain responds, and sometimes it takes a while. He doesn't get it right away. But all the videos that he publishes are the ones that he succeeded. But it's interesting. He basically, you know, calls upon his brain to, you know, to produce. Do your job, brain.
You know, I learned
That's not unrealistic. When he says, hallelujah, my brain responded.
I used to hear people in the AA rooms talking about praying a lot and prayer and the power of prayer and all that sort of thing. And what I realized after quite a few years was that prayer works whether you believe in a supreme deity or not. Because when you're practicing the act of saying a prayer, reciting the prayer and thinking about what it is you're praying about, what do you want, what are your wants and your needs and your values, you're actually auto-suggesting something into the presence of your now, your moment, that is likely to change the way you act in the future or people around you, you know.
Yep. And I fully accept that. I completely find that a reasonable perspective. But do you then have to ascribe this entity called God to that? Or do you do just as you said, that, hey, now you just, you know, strengthen some ideas, strengthen some focus, strengthen some resolve, you know?
I mean, in Buddhism, the highest value is called the process of enlightenment. Process of enlightenment is sort of the pseudo deity of Buddhism. It's like, come on, process of enlightenment, you know, do your thing and get me enlightened, you know, get me to see what I'm not seeing.
Am I enlightened yet? Are we there yet?
So, you know, so believing that the process of enlightenment really does exist, and it's sometimes unreliable, but, you know, eventually it's going to, you know, do its job. But, you know, if you didn't believe in the process of enlightenment, you wouldn't meditate. You wouldn't sit there and go, let me do some soul searching. Because if I do some soul searching, there's a chance that I'll see the light. And if I don't do it, there's a good chance I won't see anything. So
Actually,
you believe
there's
in
another path to that. I would slightly disagree with that.
Well, I mean, people do soul search. They do meditate. They do. Let me ponder this, because they believe that the process of pondering has a better chance of getting the answer than the process of having a drink of, you know, alcohol and not pondering is going to do it. So yeah, you believe in these abstractions. It's not a storybook character, but, you know, it's a spiritual process. It's some kind of a phenomenon. The phenomenon of a neural network sort of working it out and finding, you know, how to wire it up to do it, you can believe that there's a likelihood that the neural network will do the job, and that you can enhance the likelihood by engaging in certain practices that that improve the likelihood the neural network will do the job you want it to do. Pondering and meditating. Go ahead, Joshua.
Oh, I just think that your logic is sound. I've even heard a comedian use the exact same logic, which I love, and I'll just share it with you. He said, you know, I meet these women that say, "Oh, honey child, I'll pray for you. I'll pray for you, child." And he goes, "Don't pray for me. Make me a sandwich." I can hold the sandwich. I can eat the sandwich. Your prayers ain't doing shit. But so I get the logic of it, but I also think there's something innate about the personal connection from an individual human being to the rest of the universe. And that prayer or that belief system is so personal. If you come in between that, that's a dangerous place to come in between. And I'll use something as simple as, I watched a stupid movie and the guy in the movie says, every day I clap my hands and I say, today is going to be a wonderful day. And I tried it and it worked. And I couldn't believe it worked. And there's something about the brain that when you do that motion and you seal it into the memory with the clap, it's like a mantra, a reinforcing belief, because I clapped it into existence. And then whatever happened during that day, something in the back of my mind went, snap, nope, it's going to be a wonderful day. You can't fuck up my great day. And it really worked. It was really powerful. And it was the stupidest thing. But yet I think you can do that with anything, whether it be God or whatever it is. But if everybody believes it's going to be a wonderful day, it's kind of hard not to have that. I don't know if you've experienced that at your jobs or different places, your family.
I completely find that a reasonable phenomenon. Completely. I have no issue with that.
And I think it just, not to cut you off, Alex, but I think Simon Sinek, that famous YouTube talk that he did about how belief systems come from the inside out, not the outside in, I think that would be something to put into Collaborology. Of, you can talk about logic all day long, but you need a belief system for people to wrap around. And if you use that in your scaling, you can have a certain amount of people believe in something, but if you scale it to a point where there's too many people that can throw salt in your game, if you will, or too many people to not believe in Collaborology, that's a problem. So how you scale the belief itself and those rings and layers from Simon Sinek, I would definitely look into that and put that into your proposal. Because there will be a time when people don't believe, and what do you do during that time?
Education.
I'm complete.
These are those times.
I've got this line that people enjoy about educating over belief systems, and one of the things they say is that most people are about as happy as they make up their mind to be.
Yeah. And I just watched a talk by Roger Waters. I don't know if you guys know who that is. I think he's like one of the singers for Pink Floyd. And he started his talk with an anecdote about his mom. And he's a very wise guy. He knew that if he told this anecdote, then everything else could rely back on that in anything forward he said. And the anecdote was as simple as his mom saying, you do what's right because it's right. And that allows for subjectivity, and that allows for individual personal beliefs. But the of saying something that's such a broad statement that everyone can get around is what's right is very powerful, because then it means something different to each person, but you're still saying the same thing. Just sharing with you that technique is you do what's right because it's right. I'm complete. Go ahead, Sam.
So
I cut off
the very
Alex,
first COI practice that I actually recommend in that little one-pager is be good. Now, if that's different from do right, okay, we can quibble about that. But it was be good, okay? And you get to define yourself what good means for you. But the difference being, give yourself some accountability, not just with yourself, but with other people who can reflect back to you what you're doing about goodness. And that's the aspect that I was trying to put in the COI practices. So there's a lot of responsibility there. If I say good is something, like, you know, I will always give money to the poor. I'd say that's what good means to me, okay? Then at some point, when I don't do that, how do I hold myself accountable? Or if that eliminates my possibility of doing something else, which may have better impact, how do I then reconcile that? So my request is not just define good, but be accountable to yourself for being good.
And I'll just say that that's a fallacy. Do you mind if I break down the logic of why the word good will never work?
You're welcome to, but I've heard it before.
Okay, well then I won't do it. If you feel you've heard it enough, I don't want to be add on to the stack. But I would change that word.
Because right would have the same criticisms, right?
No, because if you do bad and doing bad is right, then sometimes you got to do bad.
So I've heard that before, yes.
I know you've heard that before. That's why I didn't want to say it. But I'm just saying that if I said the word right, then you could argue about what's right. But if I said the word good, then everyone's saying everyone in the world believes they're doing good. Even the worst people in the world, they think they're doing good. So good is a very dangerous thing. What's right is different than what's good.
Yeah, a psychopath will murder people and that makes him feel good. So he'll go out and murder more people.
I have one more anecdote to tell about these guys who are solving these Sudoku logic puzzles. From time to time, they'll be in the process of working out, you know, what deduction can they make next? And they get to a point where they can't find the next deduction. And they're kind of looking around the grid, looking for some place to focus their attention, and they're stuck. And a lot of us who are watching this process point out that often when the solver gets stuck, their mouse is sitting on the exact cell that they should focus on because that's where the next step is. And eventually they say, look where your mouse is, focus on that. That's, you know, intuitively, they're sort of in the part of the grid where there's, you know, close but no cigar. And finally, the guys who are solving the puzzles say, okay, let me look where my mouse is sitting. Focus on that. And yeah, and more often than not, that's exactly the place they should look. That's the next step. That's the next deduction. That's where intuition, unconscious intuition, is pointing you in the direction.
Very powerful.
Yeah, it's amazing if you watch enough of these. I watch them every day. You see this time and time again. He gets stuck and his mouse is sitting exactly on the square where the viewer sees that's the next deduction. But he's sort of looking, you know, he's not paying attention to where his mouse is sitting. Mouse is telling him where to, you know, think about that cell. That cell, you can reduce the uncertainty of it.
So my question was, I just posed is, and is God to thank for that?
Well, that's basically defines God as your intuition, your feelings, your guidance, your sort of unconscious guidance. This is what, again, it's not a storybook character, but it's a source of guidance. So it's a quiet but powerful source of guidance.
Okay, thanks, guys. I'm signing up.
I'm sorry, what was the last thing you said?
Signing out.
Oh, okay.
So the GOD in my lexicon stands for a good orderly direction, or the other possibility is the GOD is the grand original designer, or the grand original deception, whichever way you want to look at it.
Yeah. But it's, you know, it's kind of an abstract process, a phenomenon that's real, but difficult to interpret.
That's where the values are important. If you want to do something good, whatever you decide to do and think about that it's good is based. It's going to come from your value system.
Yeah.
So before you decide to do good in the world, you need to establish that values system and have it written on paper somewhere. Have it imprinted in your memory, in your mind. These are good things. Unity. What were the other two? Collaboration and trust.
But precision thinking sort of plays a role in there, and improving the faculty of precision thinking. That's what study is. That's what scholarship is. And you do this every day in the belief that ultimately that's going to pay off. There's going to be a case where that improved precision thinking is going to enable you to solve a problem that would have gone unsolved otherwise.
So it's acceptable to have a relationship with people that are fundamentalists, evangelical religious cults members. But, you know, if they're not willing to at least listen to your values and appreciate the values that you've got that are based on a more universal type of divinity, then they're not coming to the party, are they? They're not helping. They're not doing the right thing.
Yeah, they're not contributing in a powerful way. They're maybe still be contributing, but in a very weak way. Like, listen to them and do the opposite.
They're falling back on their tradition.
Yeah.
Because they believe that they believe they've got values, a system of values that are better and more higher thoughts.
The guy who's always wrong, who has a reputation for being always wrong, pay attention to them and then don't do that. You'll be better off than if you didn't pay attention. Go ahead, Joshua.
Oh no, I'm just thinking of the old business practice of people, process, and product. And starting with the people, if the guy's doing it wrong, you pull them aside and be like, hey, have you slept? Are you okay? Like the greatest lesson I learned in my life was when I was a manager at a company, and everybody told me the one person that was failing was untrainable. They're stupid, they're dumb, there's nothing you can do with this person, they're untrainable. And nobody walked up to that person and said, how are you doing? They just yelled at him for doing a terrible job. And I actually walked up to him and said, how are you? How's it going? And I was sincere about it. I really wanted to know. And he said, my father just died. And I'm not here at work today. And I went, did anyone ask this guy how he's doing? Like, people first. Like, I think that's the problem with the world is like, I've heard politicians say they just sign things because they got to take a piss, or they just didn't sleep the night before. Just like, ordinary human functionings create perturbations in a system. Like, just stopping. Like, I love Dumb Saul when he comes onto our meetings, because one of the things he made with his little meeting spicer cards was the question, are you supposed to be at this meeting? I thought that was the most pertinent question to ask anyone.
I could have
Like,
asked
people,
well, you know, how are you doing? He might have said, my career is dying. And he's trying to keep it from dying. It's true, his career is dying, and he's trying to keep it from dying. He's trying to keep it alive.
And at least that's honest. You can start the conversation there. That's a good, honest place.
Yeah.
Or I have a house with a mortgage and my wife is about to leave me, and I'm pretty sure she's going to take half my shit. And I'm a little scared, so I'm going to lie a little bit here. Like, at least we're being honest with each other.
Trying to put off the inevitable. I'm trying to delay the death of my livelihood as long as possible. Is that a smart thing to do? Well, maybe.
Isn't that how you create friends? Maybe you guys would end up going out for coffee and become really good friends.
It's not inconceivable, but it's also very unlikely.
I doubt it'll happen, but I mean, that's how great friendships are formed. You know, someone actually tells the truth.
Turn a stranger into an ally instead of an enemy.
Yep.
And that has happened. I think I have occasionally turned somebody around, but it's very hit or miss, and it ain't easy.
The hardest thing ever.
They dig in their heels, and that way they get negative attention. Well, they get attention, but maybe what they really want is the attention, and they don't care if they're wrong. They just want the attention.
One of the problems I see is that there's so many people in the world. If somebody doesn't live up to your expectations, you can go, oh, what the hell? It doesn't matter. There's 8 billion other people to choose from.
So
yeah, but there's only one. I don't know. This is my spiritual belief, is that there's only one you. So how you treat other people is between you and your belief system of the universe. I'm not going to use the God word.
But you is the name of a time varying function.
Ah, now we're getting back into it. See, the spirit and science, I think religion and science go together like that. It's so beautiful.
Yeah.
Yeah. You've got disorderly conduct in science, and you've got orderly conduct too. That when you watch things like laminar flow in water, it's an orderly process. Whereas, and then that's a physical phenomena, but it happens in the mental realm as well, between classes of people and cultures. But it's on a more deeper, complex scale there.
Alex, can I ask you a philosophical, spiritual question?
Yeah.
Okay. How many realms do you think exist? And when I use the word realm, I mean the entire earth, the way that we're taking in the information as human beings. How many different type of places exist with different type of understandings in the universe?
Well, there's many different understandings. I think there's thousands of different understandings in that type of realm, but on the earthly realm in physics, there's only one real world, and the one we live on, the one we all share. That's the common denominator.
But does everyone believe that? Because I know the heaven and hell concept has been out there. I did study Buddhism.
No,
The realm of enlightenment is another realm separate from this realm.
That takes us back to what do people believe?
My answer to that, Joshua, is that the number you're looking for is a countable infinity. In other words, Aleph null.
Yeah.
The number of realms is Aleph null.
But
So if there's I'm just going to make my point. I don't know if Sam will watch this later, but if there's accountable infinities, then there's accountable infinities of the milk in that diagram that you can pray to, which means there's an accountable affinity of belief systems.
Right.
So how do you unite an accountable affinity of belief systems?
Well, I don't know that you can't unite them, because some of them are going to be mutually inconsistent.
Mm-hmm.
But the thing is that, what do you pray for? I pray for enlightenment. I'm sitting there pondering a dilemma, and I'm saying, Lord, help me figure this out.
Is that an epiphany or an enlightenment?
Well, they're kind of synonyms. Help me get to aha. How do I get to aha?
If you know that the Lord is not going to help you, then you pray for something else. And the thing you pray for is the tools and the knowledge to find out what you need to solve the problem.
Or I pray for a subject matter expert to show up and show me the way where I got stuck. And sometimes the subject matter expert does show up, and sometimes I got to just, work it out on my own, and it might take a day, a week, a year, a lifetime.
If there's tools that are not at hand that will solve the problem, then you can pray for those tools to appear, or you can go out and look for them.
Somebody says, give me an app, give me an algorithm or an app to solve this problem. I have people on Facebook who say, Barry, do you know an app to solve this problem? And I'll say, yes, I do, or no, I don't. Or there's probably an algorithm that exists, but I don't happen to have a.
But if that person was praying for somebody to give them an app, and they came to you, they'd say, well, Barry's not God because he didn't answer my prayer.
Yeah, well, but if you ask for something, there is a non-zero chance that you'll get a constructive answer. If you don't ask for it, there's a pretty good chance you won't get an answer to an unasked question. Go ahead, Joshua.
Oh, I just heard you talk about Buddhism earlier, but the one thing that always came to me when I was studying Buddhism was praying to not want to solve the problem in the first place. So therefore you don't need the answer. I know that's, a hard, not wanting, the idea of not having desires is a really hard concept in Buddhism.
Yeah. But I actually had issues like that in my professional career where they would come to me, somebody at AT&T would come to me and say, Barry, help us solve this problem in network planning or network operations. Or help us find a better way to clean up the messes. And I'll say, I can show you ways that there's no mess to clean up. Don't do that, then we're out of a job, because my job is to clean up the mess. I just want a better mop. Yeah. No, I'm not going to give you a better mop. I'm going to make the mess go away so you don't have to clean anything up. And then they panic because, oh my God, I have to find another role to play. And I didn't anticipate that the last person to accept the solution was the person carrying the mop, because they were the last person who could find another job.
I think what you just said, I have not, what you just said there to me solves the whole problem. Like that is the problem with all of humanity is
Right.
if there is no problem, then you have nothing to do.
Right, and now that's a panic. My God, I'm
Yep.
out of work. If I can't go out and if there's nothing to mop up, I'm out of a job.
Now you've got a problem.
Now you got a problem that now the solution is I have to train you to work on a new problem that hasn't yet been solved.
Yeah, well, you can always, with that infinity idea, it means you can always come up with another problem.
Yeah, but consider the person with the mop is probably the least educable person in the whole whole organization. That's why they're the one that's taking out the garbage. So yeah, I mean that was an irony that didn't dawn on me till the end of the whole exercise. And once I understood it, that was on a moment of enlightenment. Now I see why it's taking so long to get this approved. The lower they are on the totem pole, the less they are to want to approve it because I'm putting them out of a job.
It's not surprising why the Egyptians believed in the sun god Ra. When you look at the light beams, the photons coming across Joshua's shoulder.
Right.
Yeah.
There's your God.
Well, that's the source of light.
And you see the circles it makes on the lens.
Yeah, I think the nuclear fusion, or is it fission? Which one is it bury up in the sun? Is it?
It's fusion. By the way, the fusion process in the center of the sun is generating less energy per unit volume than your body. If you look at the number of watts per cubic meter in the center of the sun, it's less than the number of watts per cubic meter of a living organism on the earth. You're hotter than the center of the sun.
And what you just said is why I would love to hear what you think of Michael Levine, the podcast he did with Lex Friedman from Tufts University, because that logic right there is part of understanding bioelectricity. And we're just on the cusp of this new field of bioelectricity. I feel like, it's been studied to a point, but I don't think we're even close to understanding how it works.
Yeah, I mean, the whole business of how biological systems, cellular systems and nervous systems and neural, this whole thing is pretty new discipline. And part of the problem is that the mathematical models that would capture it are very, very subtle, sophisticated, complex, and difficult.
Conditions.
Yeah.
Conditions have got to be spot on. They're
Yeah.
trying to manufacture a way of making green energy photosynthesis in the lab.
Yeah, artificial photosynthesis.
Yeah.
And they barely understand how it works in a leaf, in a green leaf. They have some theories about how quantum mechanics plays a role in photosynthesis. They have some ideas, but they haven't been able to replicate it synthetically, at least not good enough yet to be better than a tree with lots of green leaves on it.
Yep.
Yeah, and bio substances like fungi.
Yeah. I mean, cyanobacteria, that predates chlorophyll. Cyanobacteria in the sea was the beginning of photosynthesis.
Yeah,
But then on land, the trees did it without having to be cyanobacteria. They developed a related but distinct mechanism. But it still appears to involve some kind of quantum mechanical effect because you got to capture a photon and then use the energy of the photon to generate some organic molecule.
Yes, it's the bioluminescence of the insect world. They use that for signaling and some kind of intelligence involved there.
You know how crickets communicate? By going silent. They're all chirping. They're all chirping when everything's fine, and if there's a predator, they stop chirping, and the silence is the alarm.
Yep.
Okay.
And then there's birds that mess with the squirrels that give fake on purpose, like humans. They give the fake signals,
right,
just to pull them out. Yeah.
Yeah.
We got
Camouflage and all that stuff.
You've got magpies in Australia that are mimics. They like those parrots that talk, talking birds.
And so here we are with Photoshop. Photoshopping is catching up with the mimics of nature.
Yeah, I had a blast up in the mountains just once you're living without all those other sounds, the only sounds you're tuning into is the nature sounds. And from living up there long enough, I could tell you if there are predators around. I could tell you, I was picking up on those same signals subconsciously and consciously later. But it got to the point where when the crow would go by and he would give a couple caws, I kind of knew what he was talking about because I'd heard it so many times. And then I saw the other predator come through, or then I saw a rainstorm, or like the way the animals communicate, I think is worth diving deeper into. And I think that's the ancient knowledge that's lost, is
Look at
the
the
global
bee.
system.
Look at the
Yeah.
bees dancing to show you the direction of the honey. I mean,
Yeah.
I mean, how long did it take to figure that one out? That took a long time to figure out that the bee dancing was a signaling of the direction and the distance. It was the direction and the distance was encoded in the dance.
Go ahead, Alex.
What I find incredible about nature is when insects or animals are flocking together in huge numbers, sometimes there's a cacophony of
Yep.
noise.
Mhm.
They're all going at it at once.
Yep.
And there's just this roar. None of them are making any sense out of it, I don't think.
Well, would you guys agree that at this moment in time, humans are evolving into something different than what we were? Meaning, for thousands of years, we were geared biologically to do specific tasks.
Yeah.
And now we don't have to do those tasks anymore because we created a different environment, which is leading to an evolution in human behavior.
Yeah.
But it's also counterintuitive because it's not what our physical makeup is meant to do.
We're evolving into Homo technologicus. Look at my life. If I had been born 200 years ago, almost everything that my life is about wouldn't have existed. Technology and science and mathematics and engineering and telecommunications and none of that existed. Back in even a few hundred years ago. And I came to wonder, how the devil is it that I'm a member of a species that evolved to be a hunter-gatherer, and here I'm doing completely unrelated things that my ancestors never even heard of, let alone learn how to do? How can that even be possible, that I have the faculty of mastering all this stuff that's got nothing to do with, how the animals function? And that's a very interesting thing to ponder. Sam just came back and raised his hand.
I think that's an aspect of leveling up, Barry. So this is a simple explanation and there's no proof for it. But if we always ask this question, what did we used to do and why am I not doing it anymore? That's the reverse of the question, which is, what do we now have that we didn't used to have that allows us to do something different? And I'd rather focus on that.
Yeah.
How
the hell did we get to the moon? And
this is a gift, I'm saying. The fact that these brain-body ratios are as high as they've ever been is a gift. And so let's figure out what that can do to allow us to level up, rather than saying, oh, well, let's recognize that we had to gather, we had to hunt, we had to raise wheat, whatever, in order to get to the point we're at today. So it was a privilege that we were able to go through that. And now, if we're not able to recognize it as a privilege and an opportunity, then we don't deserve the gift that we're given. That was my point. Thank you. Josh and Alex.
I was just going to say, to go back to what Alex is saying, this little thing right here, I think is going to be around for 1 billion years. At least that's what they say.
4
so
billion.
Why don't we, 4 billion, but at least 1 billion where we can handle it. So I'm just saying, for 1 billion years, why don't we learn what the ancients learned, or what the future people learn, or go in circular time or whatever? But this thing's not going away for a while. We will go away before this thing goes away.
Yeah, either learn how to make energy the way the sun does, or learn how to make energy out of the photons that the sun sends us. And I think we'll be able to capture the photons more readily than replicate the fusion reaction.
Or instead of learning, look around. I mean, at least for me, there's bushes and trees. They already know. So why don't we honor those things that already know, instead of trying to synthetically create? I mean, it's silly. It's already perfect. I think that's enlightenment.
If a tree can capture enough photon energy to live, why can't we use our technology to capture enough photon energy to do what we want to do to run our computers and our heating systems?
Yep, exactly. Go ahead, Alex.
There's a lot of power in water, you know, there's windmills out there with big blades, but I looked at a river. I looked at the water flowing, the current in the river. And a fast flowing river, you just build a concrete block on each side of the river and you put a pole across that's on bearings and you attach to the pole these large paddles. And as the river current flows and turns these big paddles, the axle turns with a tremendous amount of torque and drives a gear ratio system and on a generator, would produce more power than a windmill and be smaller than a windmill.
We had water wheels that were milling, that would mill wheat or corn or whatever. I mean, that's basically the power supply here in New England, 200 years ago was the water wheel.
Yeah.
That was the
Imagine you've got an axle going right across the river from one side of the river to the other, and maybe a support in the center of the river as well. And then you've got about 6 water wheels on that axle.
Except that it was also the highway. So you had to leave room for the boats to get through. So that's why they had the water wheels designed not to block the passage.
Yeah, well, these rivers are too small for the small boats can get by on the side. They just leave that gap on the side for the boats. But the river's about the width of 3 double-decker buses. So there's always a space to get boats through.
But I mean, look, they built the Hoover Dam for the Colorado River, and they built it at the time when the flowage of the Colorado River was about 4 times what it is today. And now there's not enough flowage of the Colorado River to run Hoover Dam. You're getting to the point where you can't run the generators anymore. It's not enough flowage.
Well, I hope we reach a sustainable world, because I just got the new iPhone. It's on 5G and it's really fast and it's awesome. And I hope 6G doesn't use too much power and 7G doesn't use too much power. But I've been watching the car industry. There's a new car coming out of San Diego that gets 10 miles per watt hour as opposed to the 5 that Tesla gets, because it's lighter. And I think we have to find a balance between how much we need and how much we can sustain and ramp up slowly to create this new evolution in humanity.
Your reference is a man on a bicycle. In terms of transportation at the least amount of energy, a person on a bicycle, a male human on a bicycle, is far and above anything else in our technology. And that's sort of what you want to replicate. You want to get as close to as a human on a bicycle as you can using, modern technology.
What if we even slowed it down and just walk?
Well, what if
that takes more energy than a person on a bicycle. For the amount of energy it takes to walk, you can get a lot farther on a bicycle.
Yeah, well, you can
certainly on level ground you can.
But what about for the amount of possible economic transactions on the way when you're walking?
Well, if you want to have a conversation, if you want to walk along with somebody and have a conversation like this, then it's hard to do that on a bicycle.
That's
true. You want to go for a walk and talk, you got to go for a walk and talk, not for a bike and talk.
When you
On the other hand, if you had radio headsets, then you could bike and talk. Put a mic, radio walkie-talkie in your headset, then that would work.
Yeah, you got a GoPro on your bicycle. But the thing is, when you get home on the bike, you can take the back wheel off and put your bike on the treadmill and generate power.
About 100 watts tops. It's really hard to produce more than 100 watts on a bicycle unless you're really an athlete.
Yeah, I got two big solar panels that each produce about 340 watts.
Yeah,
so I've got nearly 700 watts of solar power from those 2 panels.
And that's more than you could do pedaling a bicycle. You'd become exhausted too quickly.
Yeah, I apologize, guys. I got to go take care of the little one. Thank you so much.
Unless
Sunday.
Sam has anything more, then maybe we'll go ahead and shut it down.
Let me save the chat.
Do that, yeah.
Okay, done.
All righty, Sam, if you're there,
So-
you can shut it down. I don't know if I have the power to shut it down this time or not. I didn't.
So,
notice.
sayonara.
Yep. Okay, Sam. Let me just see if yeah, I don't have the power to shut it down or stop the recording. Let me just double check that. I don't think I do. Nope. I don't. So I'm just gonna sign off. Sam, you'll have to end it when you want.